Okay, so this is another video with two more examples of limits, one that does exist and one that does not exist. So the first one I want to look at, this is f of x is sine x over x, and I want to consider the limit as x approaches 0. Okay, so now one thing to notice is that this function is undefined when x equals 0, right? If I'm dividing by x, then 0 is not in the domain because I would be dividing by 0. So this function is undefined when x equals 0, and that's going to look like a hole on our graph. So if you kind of look at this graph, Desmos, like it doesn't show the hole right away, but if you try to mouse over what 0 is, it tells you that 0 is undefined, and you see this hole in the graph. So it kind of only shows it when you go right on there. So there's a hole in the graph right there. So f is not defined at x equals 0. That's okay if I'm looking at the limit as x approaches 0. It's okay that the graph is undefined at x equals 0. In general, when I'm looking at a limit as x approaches, let's say a, what happens at x equals a does not matter at all. It's completely irrelevant for what the limit is. What the limit is asking about is as x is close to a, as x is approaching a. But what actually happens at that value, it does not matter at all for the limit. So here, the function is undefined. It doesn't matter. We can still ask about what the limit is. So as x approaches 0, the question is, what is the y value approaching? And if we zoom in here, it sort of, it looks like it's approaching 1. The y value is getting very close to 1. So kind of out here, maybe it's, more like 1/2. But as we get closer and closer to 0 from either direction, right? So it's kind of close to 6/10 here. But as we get closer and closer to x equals 0, the y value is getting closer and closer to 1. And as we zoom in on this, kind of, you can see that it's the y value is getting very close to 1 as x is going to 0. And this is sort of just a heuristic, like looking at the graph. It can just give you an idea. We'll talk about more precise ways to actually prove that this limit is 1 using some techniques from algebra or geometry later. And we'll talk about rigorous ways to show that this is 1. But looking at the graph of this function can give you an idea that probably the limit as x approaches 0 of this function is 1. And it is. Okay, so now the second one is a very similar function, but in this case, the limit's not going to exist. So instead of sine x over x, the function that I want to graph is sine of 1 over x. And I'm interested again in what's happening as x is approaching 0. And you can see this function's getting kind of crazy as x approaches 0. You can kind of think about what's happening as x is approaching 0, kind of. Let's say x is getting close to 0, but it's positive. So let's kind of look at the right-hand side of the graph here. As x is getting close to 0, 1 over x is growing. It's getting to be a very big number. You're dividing 1 by something close to 0 but positive. So it's like if x was like 1 over 100, then I'm getting sine of 100. If x is like 1 over 1,000, I'm getting sine of 1,000, right? If x is 1 over 10,000, I'm getting sine of 10,000 here. So I'm kind of taking sine as the input is getting larger and larger. And so, for example, let's just look at the graph of sine itself. So the graph of sine, it does this thing where it oscillates between 1 and -1, right? And so as the input goes farther and farther out, it's kind of doing this thing where it's just oscillating back and forth between -1 and 1. And so now if I look at this function sine of 1 over x, so if x is tending to 0, then what is getting input into sine is getting larger and larger. And so the output is going to do this thing where it oscillates between -1 and 1. And so it's going to oscillate over and over and over again. And so there's no sort of meaningful number that I can say that this function is approaching, because it's hitting all of the values between -1 and 1, and it's hitting them over and over and over again. And if we zoom in, it kind of, it gets very dense near x equals 0, because it's oscillating over and over and over again, infinitely many times actually. And so there's kind of no y value that this is getting particularly close to, because it's hitting all of them many, many times. And so this limit does not exist. The limit as x goes to 0 of this function, sine 1 over x, it does not exist.